Good morning, guys. All right, so we're going to continue on with our work with right triangles today. So last time we used the geometric mean to find different lengths in a triangle when the altitude was drawn from the right angle in a triangle. So we had a nice little right triangle here. We'll call it A, B, C. And we drew in the altitude from that right angle. We'll call that D. And it gave us these three different similar triangles. We had a small, we had a medium, we had a large. And we were able to use different formulas in whether we had the altitude or the leg in order to find the missing piece in those triangles. Today, we're going to work with Pythagorean theorem, which is something we've already done before. But we're going to continue working with it, do a little more involved problems in order to find the sides and missing right triangles. We're also going to use the converse of the Pythagorean theorem, which is going to help us to classify triangles as either right, acute, obtuse, or in some cases, not a triangle at all. All right, so you guys can take these notes on a separate sheet of paper. You could just do them right on here, whatever you want to do. Okay, so Pythagorean theorem, we all know, is used to find the missing sides of a right triangle. Sides A and B, which would be these two, are what we call the legs of the triangle. And then side C is called the hypotenuse. And it's important to note that it is always across from the right angle. Okay, important to note that it is always across from the right angle. For any right triangle, the formula that we're going to be using for Pythagorean theorem is a squared plus b squared equals c squared. And we know that that c squared has to be the hypotenuse every single time. All right, so let's take a look at examples 1 and 3, and then you guys are going to try 2 and 4 on your own. So when I go through and do these problems, I like to write down on, or like actually mark on my triangle A, B, and C. Like I've said in the past when we've needed to use Pythagorean theorem, you can switch A and B. It doesn't really make a difference, but that C value always has to be directly across from the right angle. So we've got our right angle, we've got our C value. Now, the way I'm looking at this, I would probably call the 8A and the 13B. But again, if you switched those, it doesn't make a difference. So now we just set up our formula. We have A squared plus B squared equals C squared. We're solving for C in this case. Let me call it X. It's labeled X. So X squared. Okay, I'm just going to square. I'm going to do the 8 squared and the 13 squared directly on my calculator. So 8 squared plus 13 squared gives me 233. Now to undo an x squared, you take the square root of both sides. And I get x is about 15.3. Okay, and you can always just, if you have to round to the nearest tenth, that's fine. You can just do so. Okay, let's take a look at our next example, number 3. Okay, I'm going to do the same thing. My C value is always across from my right angle. And then I'm going to call 7A and XB. So this problem is a little bit different because we're not finding our hypotenuse anymore. We already know what the hypotenuse is. So I'm still going to set this up as A squared plus b squared equals c squared. Now you just have to be careful here because I can't do 7 squared plus 9 squared in the calculator. That's not what it's telling me to do. I have to square them separately. So 7 squared is 49 plus x squared equals 9 squared, which is 81. Oops. I'm going to subtract 49 from both sides. I get x squared equals 32. And then to find the actual x value, we take the square root of both sides, and x is going to be about 5.7. Okay, so you guys can pause this video and try numbers 2 and 4. Come back and check your work when you're done. All right, so hopefully you guys pause and finish those 2 examples. For number 2, we end up getting x is about 34.8. And for number 4, x is about 23.8. Okay, so that's the Pythagorean theorem, just a little review of that. We've used it before. I'm sure you guys have used it even before geometry. But let's move on to the Pythagorean converse. All right, so the Pythagorean converse is going to help us identify what type of triangle we are dealing with. So we have our normal a squared plus b squared equals c squared. So if the legs squared and added together is equal to the hypotenuse squared, then the triangle is a right triangle. Okay? If when we add a squared plus b squared, so if a squared plus b squared is less than c squared, okay, then the triangle is obtuse. And then finally, if a squared plus b squared is greater than c squared, then the triangle is an acute triangle. Okay? So, this is how we're going to do these problems. Now, if you read the directions here, it says first determine if the 3 sides could form a triangle. Okay, we haven't really talked about that yet, but then in the directions it tells us how to do that. So recall from earlier, the sum of the 2 smaller sides must be greater than the 3rd side. So let's just do a quick example here. So do the sides 2, 4, and 8 make a triangle. Okay, because you can't just pick any 3 side lengths that you want. It's possible that if you pick 3 side lengths, it doesn't make a triangle. So we have to check, is 2 plus 4, the sum of the 2 smaller sides, greater than 8? 6 is not greater than 8, therefore the sides 2, 4, and 8 would not make a triangle. Okay, so you have to test that first for all of these problems. So let's look at our first example. Okay, so first we need to check, is 3 plus 7 greater than 9? And the answer is yes. Sorry, I'm still getting used to this stylus. 3 plus 7 is greater than 9. So now we have to use 3 squared plus 7 squared and figure out, is it less than, greater than, or equal to 9 squared? 3 squared plus 7 squared gives me 58. 9 squared gives me 81. So because of this, it's pretty evident that a squared plus b squared is less than c squared. Therefore, this would be an obtuse triangle. Okay. Now, number 2. 20 plus 21 greater than 29. That's a yes. Okay, so we can move on. All right, so now we're going to actually do 20 squared plus 21 squared. Compare it to 29 squared. We have 841 compared to 841. So it's obvious that a squared plus b squared is equal to c squared. Therefore, this is a right triangle. Okay? All right, so just like last time, I want you guys to pause the video and answer numbers 3 and 4. All right, so here's your answers for number 3 and 4. Hopefully you guys got the same. Number 3 is not a triangle because 4 plus 11 is not greater than 16. And number 4 is an acute triangle because a squared plus b squared is greater than c squared. Okay? All righty. All right, that's it for the lesson today, kids. What I want you to do are these 1, 2, 3, 4, 5, 6, 7 problems as classwork. You're going to submit them as a photo on the Google Classroom assignment page, just like you guys did yesterday with the exit ticket. Make sure you show all of your work. If you want to print this page out from online, you can, but you don't have to. You could just do it on a separate sheet of paper. Please be organized and neat. It's really hard for me to read some of your work if it's really sloppy, so try to do it as neat as possible. After you do that, you could work on these 5 extra credit questions. So you guys are going to have a quiz either later this week or early next week on what we've done so far with right triangles. Every one of these that you get correct will be 1 extra credit point, and this will be due with your typical assignment. And then when you're done with that, you do have a worksheet for homework. I only want you guys to do, let me see, the odds. So odds only on the homework worksheet. Next class, we'll work with special right triangles. And then you'll have a quiz, like I said before, on these items. Okay, so if you have any questions, be sure to email me. I know Google Classroom was a little bit glitchy yesterday towards the later afternoon, so hopefully you can get on here early and do your stuff in the morning so that it's not so glitchy. If you guys have any questions, let me know. See you guys tomorrow.